Hi, welcome back to my YouTube channel. Please do well to subscribe to Massa Tutorial so that whenever I post any video, you'll be the first to receive it. Alright, now we are moving on with our topic. The right-angled triangle. Pythagoras theorem. The right-angled triangle. Pythagoras theorem. Under the topic, we have the subtopic application of Pythagoras theorem. Application of what? Pythagoras theorem. So now, let's recall ourselves of what we learned last time or in the last video. We said that if you have a right-angled triangle, whose measure is up to what? 90 degrees. And we state that what Pythagoras theorem is what? Is the square on the what? Hypotenuse. It is equal to what? The sum of the what? Squares on the other two sides. Now, if a side faces or if a side is opposite to what? This angle, 90 degrees, then that means that side we are referring to is the what? Hypotenuse. So please don't forget. Don't forget at all. The side is opposite to what? To this 90 degrees. Then that side is the what? Hypotenuse. That's the longest side. Then now, this is referred to as what? Our two sides. As our two sides. And we stated that what? The square on the hypotenuse is equal to what? The sum of squares on the what? Other two what? Sides. So that's what Pythagoras theorem states. So we have this one, 90 degrees, then we have A, B, then C. So it means that the square on this hypotenuse, A squared, equals what? The sum of the squares, that's B squared plus what? C squared. This. Now we can make A the subject, we can make B the subject, we can make what? C the subject of this relation or of this equation. Now to make a variable the subject means that what? To let the variable stand on its own. So now we can make A the subject here. So you can see that A equals what? We take what? The square root of what? Both sides of the what? Equation. So to what? To remove this square. So it means that I'll take the square root here, then I'll take the square root there. So the square cancels what? The square root. So I'll get A equals square root of what? B squared plus C squared. Also, if you want to make B the subject, so it means that A equals what? Square root of what? B squared plus C squared. So we've made A to what? Stand on its own. Now, let's make B the subject. So we have A squared equals B squared plus C squared. To make B the subject, you have to send this variable or this letter to the left-hand side of the equal sign. Now, this variable is adding to what? B. So when it crosses this equal sign, it becomes what? Negative. So I'll get A squared minus C squared equals B squared. Now, what do we do again? We have to take the square root of what? Both sides of the equation to remove what? This square. So now, square root here, then square root there. So I'll get B equals the square root of A squared minus C squared. So we've made B to stand on its own. Now let's make C the subject of this relation. Now, A squared equals B squared, then plus C squared. So now, to make C the subject, now B is adding to what? C. Now B is positive. So when it crosses this equal sign, it becomes negative. So A squared minus B squared equals C squared. Right. So now, what do I do now? We what? take the square root of both sides. So now square root. So I get C equals square root of A squared minus B squared. So that's how it is. So now let's move on to our new subtopic for today: applications of Pythagoras theorem. How can we apply Pythagoras theorem in our daily life activity? How can we apply Pythagoras theorem in our daily life activity, or in our world we are living today? So now, if you get to my JHS students, if you get any application question on mathematics, please, I'm pleading with you to read it 3 times or 4 times, because we are working within time. So please and please and please read it 3 times so that you underline the key words inside. You take note of every single key word. Please and please. Then you jot it down. It's very, very necessary. If you don't understand it, please don't tackle the question. Alright, so application of Pythagoras theorem. Let's do 1, 2, 3 examples and let's take it from there. So we have a ladder leans against a vertical wall of height 12 meters. If the foot of the ladder is 5 meters away from the wall, calculate the length of the ladder. Calculate the length of the ladder. Alright, we have a ladder leans against a vertical wall of height 12 meters. If the foot of the ladder is 5 meters away from the wall, calculate the length of the ladder. When you get an application question like this, please just draft something down. Just draw a diagram, sketch a diagram, so that you get proper understanding of this question. Alright, so now let's see. Solution. A ladder leans against a vertical wall of height 12 meters. I believe you all have seen a ladder before. A ladder, in quotes, actually. So a ladder. So a ladder leans against a vertical wall of height. So let's see the wall. This is my wall. That's my wall. So we have this ladder which is leaning on the wall. Then we have the horizontal ground. So this is my ladder. And we have the wall. Then we have the horizontal ground. That's the horizontal ground. So we can see that the wall is perpendicular towards the horizontal ground, which is 90 degrees. When you hear perpendicular, it means 90 degrees. Alright. So now, let's see. A ladder leans against a vertical wall of height 12 meters. So it means that the vertical wall, the distance of this wall, or the length of this wall is 12 meters. Is how you getting it? And now, if the foot of the ladder is 5 meters away from the wall, if the foot, we all know the foot of this ladder is what? 5 meters away from this wall. So that means from this point to that point here is 5 meters. Calculate the length of this ladder, or calculate the length of the ladder. Now, if you want to calculate the length of this ladder, then you have to apply what? Pythagoras theorem. Because you see this shape is what? It's a right-angled triangle. So you have to use what? Pythagoras theorem to solve this question. So you can write using Pythagoras theorem. So Pythagoras theorem states that what? The square on the hypotenuse, you know where the 90 degrees is opposite towards this side. So it means that this side, this ladder is the what? Is the hypotenuse. So let's represent it by what? L. Then the wall by what? W. Then the horizontal ground by, let's use ground. So let's say G. So I'll get what? L squared equals W squared plus what? G what? Squared. So we proceed as L squared equals W is 12. So 12 all squared. Then plus G, which is what? 5 all squared. So L squared equals 12 squared means what? 12 times 12 plus 5 all squared means 5 times 5. So L squared equals 12 times 12, 144, then plus 5 times 5, 25. Right. So 144 plus 25 gives us 169. Very, very simple calculation. So now, what do? We want L. So we have to take the square root of that. So 169 square root. Right. So I have L, which is equal to the square root of 169 gives us 13. 13, then our unit is what? Meters. 13 meters. So calculate the length of the ladder. So therefore, the length of the ladder is 13 meters. Very, very simple. The length of the ladder is 13 meters. So please check the solution, then analyze some one or two things, then we proceed from there. Alright, let's solve another example. So now we've seen how the application question is strong. So now sit upright. Right. Okay. Let's see this question. The sides of the square are 4 centimeters long. calculate the length of a diagonal. Calculate the length of a diagonal. So we have this. The sides of a square are 4 centimeters long. Calculate the length of a diagonal. So now, what is a square? A square is a plane figure, or it's a plane shape with what? 4 equal sides. A square is a plane figure or a plane shape with what? 4 equal sides. So solution. Let's see. So I have my square. So we have to sketch the square. So all the sides are equal. So I have 4 centimeters here, 4 centimeters here, 4 centimeters here, and 4 centimeters here. Right. So calculate the length of a diagonal. So now, this is my diagonal. That's the diagonal of a square. A diagonal. That's another diagonal of a square. When you do it like this, you get another diagonal of a square. So you choose one in which you can work with. So 90 degrees, then 90 degrees. So now, let's label here point A, point B, point C, then point D. So now I can consider what? Considering let's say triangle BCD. Considering triangle BCD. So I can what? I can sketch that, which is D here, C, then B. Then I have mine 4 centimeters, 4 centimeters, which is 90 degrees. So that's it. So how can we calculate the length of this diagonal D? So we now know that this shape is a what? It's a right angled triangle. So it means that we use what? Pythagoras theorem. So we're using Pythagoras theorem. So now, once you apply Pythagoras, it means that what? The square on the hypotenuse is equal to the sum of the squares on the other two sides. So now, which is the length of BD is the hypotenuse, because this 90 degrees is opposite to this length here. So the length of BD all squared equals this side, then this side, which is the length of BC all squared, then plus the length of CD all squared. So the length of BD all squared, let's denote it as what? D. So D squared equals BC, which is 4 squared, then plus CD, which is another 4 squared. So D squared equals 4 squared gives 4 times 4, then plus 4 squared, 4 times 4. So now D squared equals 16, then plus 4 times 4, 16. So now D squared equals 6 plus 6 is 10. 6 plus 6 gives what? 18. Then carry 1, which is what? 38. So now we will take what? The square root of both sides. So D squared, square root here, then 38, square root there. So D gives us what? Square root of 38 centimeters. So D gives us what? Square root of what? 38 centimeters. So that's the diagonal. Now, the square root of 38 to be a little bit what? Difficult. But we can see some trick. Let's see something here. Let's see whether I can recall. Yeah. 1 times 1 gives us what? 1. 2 times 2 gives us what? 4. 3 times 3 gives us what? 9. 4 times 4 gives us 16. 5 times 5 25. 6 times 6 what? 36, right? Then 7 times 7 is what? 49. Okay. So now, this one, you can see that square root of 38. So now, when you take what here? When you take square root of 36, it will give us what? 6. Square root of 49, it will give us what? 7. But watch here, square root of 38, there is no exact value for that, right? So it will be what? Somewhere between what? 6 points, that 6 point, let's say 2, 3, about that place, right? Because this square root of 38 will be between what? Square root of 36 and what? Square root of 49, right? So the answer is what? 6.23, that place, right? Okay, so now that's it. So please, when you get to the senior high level, you use calculator, but here there is no square root for 38, so you have to leave it like that. We will not penalize you for that, but if you want to proceed and you want to get your answer, then it's up to you. Alright, so I'm pleading with you that you leave it what? Here. So that means the diagonal, or the length of a diagonal, is what? Square root of 38 what? Centimeters. So that's the solution for that. Let's solve another question. So please watch the solution very, very well. Watch the solution very, very well. Alright, so now let's see this question. Then I'll give you more word problems to go and try on your own. If you have any problem, please drop it at the comment section or contact me on 0541086 489 0541086 489. Alright, thank you. Alright, so let's solve last example. So we have a ladder. A ladder is 25 meters long. The foot of the ladder is 7 meters away from the base of the wall. How far up the wall is the top of the ladder? So, solution. So look at this question very, very well. Look at it very, very well. And analyze this, then tell me the correct approach. Say it to yourself that I can do it. So analyze the question, then tell me the correct approach. I'll be right back, okay? So now, I'm back. I believe you've done something, right? So now, let's go. The ladder is 25 meters long. The foot of the ladder is 7 meters away from the base of the wall. How far up the wall is the top of the ladder? The ladder is 25 meters long. So now, let's do our sketch here. So I have my wall. Then ladder here. So my wall, then my ladder, then my horizontal ground here. So now, then 90, because the wall is what, perpendicular to the horizontal ground. So here is W, then here is G, then here is L. So a ladder is 25 meters long. Now, they are what? Giving us what? The length of the ladder, straightforward. So here is what? 25 what? Meters. 25 meters. Then now, the foot of the ladder is 7 meters away from the base of the wall. So this is the base of the wall and the foot of the ladder. So that means they are talking of what? The horizontal what? Ground, which is what? 7 what? Meters. Please, are you getting it? The foot of the ladder is 7 meters away. The foot of the ladder is 7 meters away from the base of this what? Wall here. So that means they are talking of what? The horizontal ground. Now, how far up the wall is the top of the ladder? That means he wants you to find for what? The height or the length of the wall. The length of the wall. So I have my wall. So now still we have what? A right angled triangle. So we have to use what? Pythagoras theorem in solving this. So we're using Pythagoras theorem. So we're using Pythagoras theorem. Using Pythagoras theorem in solving that. So you can say that what? Where this 90 degrees is opposite to this side, that means this 90 is opposite to what? To the length of the ladder, which is what? 25 meters. So it means that this ladder is the what? Hypotenuse. So I get it as what? L squared equals the sum of the squares on the other two sides, which is what? W squared plus what? G squared. So let's proceed. L squared, which is what? 25 all squared equals W, we don't know W, so W squared plus G squared, which is 7 all squared. Now 25 squared gives us, yes, 25 times 25, 5 times 5, 25, you get 625 equals W squared plus 7 squared gives us what? 49. So now you group like terms, right? Now this one becomes what? An equation. Very, very simple what? Equation. So you group like terms here. So now positive 49 crosses the equal sign, making what? It becomes what? Negative 49. So 625 minus 49 equals W squared. So 625 minus 49, we get, is it 576? Let's see, 625 minus 49. Now 9 from 5, it can be to give us a negative value, but we don't want that. We want what? A positive value. So we go what? 10 from these two places, right? Okay. So now here 10 plus 5 we get what? 15, right? Okay, so now this one reduces to 1, right? Okay, so 9 from 15 we have what? 6, right? We have 6. Then 4 from 1 it can be, so you borrow what? 10 from the 6. So here reduces to what? 5. So we have 10 plus 1. So 10 plus 1 becomes what? 11. 4 from 11 is it's 7, right? So which is 7. Then 5, here is 0, right? 5 minus 0 is 5. So the answer is what? 5, 7, 6. So 5, 7, 6. 5, 7, 6. So now what do? Equals what? W squared. So now you know that 576 equals what? W squared is the same thing as what? W squared equals 576. So we'll take what? The square root of both sides to cancel the square. So square root here and square root there. So I have W equals square root of 576 gives us 24. 24. So please, I'm pleading with you to learn your square roots, because 24 times 24 gives us 576. So I'm pleading with you to learn your square roots, your perfect squares. They are very, very important. So now W equals 24 meters. 24 meters. So therefore, the height wall is 24 meters. So please do want to subscribe to my YouTube channel. You enjoy more of the GHS mathematics videos. Please, if you have anything, please drop it at the comment section, then I'll attend to you later. Alright, so please look at the solution and see how it works. Alright, so let me give you assignments, take home assignments, so that you try on your own. Please, when you are done, don't hesitate to drop it at the comment section, so that I'll get time to attend to you for any information or for any further enquiries. Please do call 054 10 86489. I'll surely pick up your call. Alright, so let's write this assignment down. So numero 1, we have the foot of a ladder. The foot of a ladder is 2 meters. 2 meters from a wall, and the top of the ladder is 6 meters above the ground. Calculate the length of the ladder. 2. A rectangle is 12 centimeters long and 9 centimeters wide. Calculate the length of a diagonal. Calculate the length of a diagonal. 3. The height of an isosceles triangle is 6 centimeters. Find side if the length of the two equal sides is 10 centimeters. So I have 3 questions for you. Please do all to try them and put it or drop it at the comment section so that I get time to attend to you individually. Alright, please do all to subscribe to my YouTube channel, Massa Tutorials, to enjoy more of my GHS mathematics videos. Take heart to drop more SHS core maths and elective mathematics. Alright, so we'll meet on our next video to complete or to solve more of the application of Pythagoras theorem. Then we'll do our last subtopic, that's Pythagorean triples. Then we'll end our topic, the right angled triangle. That's Pythagoras theorem. Right, stay tuned. God bless you. Bye bye.